Hi, you're watching Floyd Steinberg's YouTube channel. I've got this Alesis Micron for cheap from eBay, and the previous owner said it's got a distorted output. Normally these go on eBay for around 300 or 400 bucks. I sense there's an opportunity to earn some money here by reselling this after I had a look at this. So I'll try to find out what's wrong here and what's necessary to fix it, and if I'm able to fix it. The Alesis Micron is an 8-voice polyphonic virtual analog synthesizer, a downsized version of the Ion. It has 3 oscillators per voice and can apply frequency and ring modulation to its oscillators. And there are 2 sliders, 1 mod wheel and 5 knobs for live tweaking your sound on the synth, and also a tiny LCD for editing sounds and system parameters. The previous owner sold this specimen as broken for spare parts, but to my delight it turns on just fine and happily displays the current patch on its LCD. I then found out what the guy meant by distorted sound. All the patches sound weird and detuned and wobbly, like all the modulations are maxed out all the time. Well, my experience in repairing electronics or synthesizers is practically non-existent, and I should really leave this to professionals. Problem is, such professionals are really rare, and usually they don't have time for such comparably cheap and common devices. So for better or worse, I'm left to YouTube tutorials and trying it myself. So a good starting point for troubleshooting electronics is to get hold of your device's service manual. Luckily, these are easy to find online. A quick look at the Micron's manual told me I can go into diagnostics mode by holding down both octave buttons while turning on the keyboard. And doing exactly that immediately confirmed my suspicion that all the user interface controls were firing all the time without even touching them. Here you can see them sending random values. No wonder the sound is distorted. So, on most synthesizers you can disable local mode, which means you can just turn off its keyboard and user interface controls. And I did that and instead connected my nano keys to the synth. And aha, now we've got clean sounds, that's great. Problem is, by turning off local mode, I've deprived myself of using the already limited live tweaking abilities of the Micron. So let's open up this thing and take a look at the inside. Luckily, disassembling the keyboard is really easy. Just remove all the screws holding the bottom plate in place and then unscrew the audio circuits on the back of the synth. You should now be able to carefully lift up the bottom plate, revealing the keyboard and an assortment of 4 circuit boards. The Micron has a very clean layout, so it's relatively easy to reassemble it. Nevertheless, it's a very good idea to take photos of the process, so you can look up where each part belongs later. You should now unplug the LCD power connector from the mainboard, and after that you can put down the bottom lid onto your desk and start removing all the screws which attach to 4 PCBs to the case. And once you removed all the screws, you can then just pick up the PCBs, reconnect the LCD and put away the case. Now, remove the 8 screws holding the mainboard and the 3 mod wheel LEDs in place, and then you can also put away the bottom plate, leaving us just the circuitry. Let's lovingly rearrange the synth innards on the table. If you take care so the PCBs don't touch each other, I think it's relatively safe to connect the audio MIDI and the power brick and turn this thing on. Let's play some notes to see if the problem persists. Yeah, still sounds horrible. So putting on my Sherlock hat, I saw that both the mod sliders and the mod wheel and the 3 knobs all have in common that they're connected to the middle PCB. So the next logical thing to do is to unplug that PCB and then see if the problem still persists after that. Okay, I have now narrowed down the problem to the middle PCB. Let's take a closer look at that. So I have a multimeter here, and the first thing I want to rule out is that the ribbon cable is damaged. So using the right setting on the multimeter, I can measure if the cables are broken. A beeping noise means the current can flow without resistance, so that part of the cable is okay. So I'll just insert a pin on one end and hold the multimeter's pin onto the PCB and check all 16 parts of the cable. And as every connection is beeping here, the cable seems to be not the problem. The next usual suspects are the capacitors. These electronic parts often dry out or explode, leaking the chemicals onto the PCB. Faulty capacitors can easily be spotted by the bulging tops or by visible spillage on the PCB. These capacitors here look fine though, so I guess those aren't the culprits here too. The next thing to check is if there are broken solder spots, which act as resistors. These can normally be repaired by reheating them with a soldering iron, but in my case that didn't help the situation either. So the only thing remaining as a possible cause of the failure are the potentiometers and the 3 chips. I think it's safe to say the potentiometers aren't the problem here, as it's highly unlikely they'll start sending random values all the time when they fail. Normally, when these fail, they stop picking up the movement. So I think one or more of the 3 ICs on the board are damaged. If we look at the traces, we can see they all lead to the middle IC here, so I'm placing my bets on this one. So, of course, I've got the worst case scenario. What I need to do now is to take a look at the service manual again and determine what kind of chip this is. On this schematic, I can see that this part is called CD4051. I can also see a part named LM339 and 7HC595. So let's head over to an electronic parts store and search for these parts. Luckily, the first store I visit has all these components, and I learned that CD4051 is a so-called multiplexer. Its purpose in life is to take a higher number of input signals and route them to a lower number of output signals. LM339 is a comparator chip which can pick up difference in voltage. If you ask me, that sounds highly suspicious. And finally, 74HC595 is a shift register, which in short words can store and transfer incoming data. I don't think that this part is faulty, but as these parts are cheap, let's order one anyway. And I also ordered replacement potentiometers, and that's it. Oh, and please don't take anything I said for granted. Those were just some educated guesses and I really have absolutely no clue what I'm doing here. So if you found a mistake in what I did here and if I bought the wrong parts and you know better, please leave a comment down below. I'd really appreciate that. Thank you. Oh, and while we're here, let's also take a look at the mainboard. Now, I don't really know what's going on here, but these set of ICs on the right side seem to be the 8 digital oscillators or DSP chips, as they're labeled voice 027 and effects. On the left, we've got a Coldfire MCF 5206EAB54 embedded microcontroller. This is a system on a chip, and I suppose this is where the operating system and the main functions reside. And this big IC here is an EP1K30 programming logic controller, which is normally found in industrial machines, and I guess its purpose here is to control the sound chips here on the right side. And yeah, here we have this tiny LCD, and on the back of the board there are 5-pin MIDI sockets and audio inputs and outputs, and the sockets for the control paddles. Yeah, did I mention the Micron has a built-in vocoder? I guess I'll show that one off in one of my next videos. So all I can do for today is to wait for these parts to be delivered, and I'm really sorry I can't show you working synth today. But for now, here's a short demo of how the Micron sounds without the live controls. Here's a rendition of Jean-Michel Jarre's Equinox Part 1, just played on the Micron without any external effects. And that's it for today. I hope you found this interesting and useful, and if you did, please consider subscribing to my channel and hitting that like button. And as always, thanks for watching, and see you again very soon. Bye bye.